hadn't been simple to hit the moon with Ranger, and Soft Landing Surveyor had been exceedingly difficult. Lunar Orbiter presented a set of problems different from Ranger or Surveyor. It was designed to circle the moon with a pair of cameras to photograph large areas of the Apollo landing zone and give good close-up pictures of many possible landing sites. Somebody called it the Flying Drugstore because it develops its own film. The spacecraft also carries an electronic readout system to scan its photographs and send them back to Earth. Lunar Orbiter was an impressive advance in lunar photography. Here was a first close look at large pieces of the moon. 16,000 square miles of the Apollo landing zone, with a resolution 100 times better than Earth-based views. For the manned lunar landing, scientists hope to find a string of sites in groups of 3. Each group a series of 5-mile-wide ovals strung out in a straight line. Each site would have to be crater-free, have no large boulders, and no surface slopes steeper than 7 degrees. Of all the areas photographed by the lunar orbiters, only a few were expected to prove smooth and level enough to meet all the Apollo landing requirements. The spacecraft photographed several suitable areas. Working with the photographs, scientists observed that the smoothest terrain appears to be the darkest. Using degrees of brightness as a yardstick has made it possible to measure the roughness of the moon's surface. Really smooth areas are hard to find. Orbiter missions have resulted in the selection of 8 possible Apollo landing sites. The most promising seems to be a broad plain on the southeastern part of the Sea of Tranquility, just east of the crater Maskelyne D. Its surface is flat. There are no deep craters, few boulders. The other 7 sites stretch along the equator from the Sea of Tranquility to the Ocean of Storms. There was now sufficient data to pinpoint Apollo landing sites for the first mission. In terrain like this, the first lunar landing craft will touch down and man descend to take his first exploratory steps on the moon. Orbiter also photographed the far side of the moon and found it to be even more heavily cratered than the face. These were bonus shots made because the cameras had to be in continual operation until all the film was exposed. The first high-quality pictures taken of this area, they covered 80% of the moon's hidden face. One of Orbiter 2's bonus pictures was a shot of the crater made by Ranger 8 when it impacted the moon. The freshness of the crater was determined by measuring the brightness of the volcanic rock around the crater. Originally concentrated and dark in appearance, the material was now powdered and brightened by the force of the Ranger collision. Lunar Orbiter not only provided outstanding photographs of the moon, it also helped improve our earthbound measurements of the moon's shape and its gravitational field. Micrometeoroid sensors on board discovered that a spacecraft orbiting the moon has no more chance of being hit than one in orbit around Earth. Measuring radiation, Lunar Orbiter 1 experienced 2 solar flares after completing its photography. Flares that would have spoiled its pictures had they occurred earlier. Lunar Orbiter 3 photographed this great 400-mile-long fault, half as deep as the Grand Canyon, and on another part of the moon, a mountain towering 6,500 feet from the floor of a crater. Other orbiter photographs reveal many craters filled with what is apparently volcanic debris. Here is a wealth of material for continued study by geologists and other scientists. For example, the crater Copernicus is one of the most prominent features on the moon. Until not long ago, this photograph, taken through the 120-inch reflecting telescope at the Lick Observatory in California, was the best available. This is Copernicus as seen by Lunar Orbiter 2. 60 miles wide, 2 miles deep, the crater dominates the face of the moon. Thoth, the keyhole-shaped crater in the foreground, is about 13 miles across and nearly a mile deep. Thoth is 33 miles from Copernicus. Much of this distance is covered with debris blasted from Copernicus by the impact of a giant meteorite billions of years ago. Rounding the back shoulder of the moon, one orbiter got an exceptional shot, the first photograph of Earth seen from outer space. From afar, Earth seems shrouded in clouds, much as Venus has always looked. To scientists, this photograph suggests that Venus may not be hidden beneath a perpetual cloud cover. A TV camera close enough to photograph Venus may find holes through which to see this planet with greater clarity. Who knows what a closer look at the evening star will bring? What answers may be found? Or what new questions man may have to ask about the nature of the universe? Other surveyors have touched down near the Landsberg crater in the Ocean of Storms. And in the Sea of Tranquility, pressing their unmistakable footprints into the lunar surface. Like their predecessor, these surveyors took a good look at themselves and then turned their television cameras on the lunar countryside. One of the most unusual features of Surveyor 3 was its surface sampler. A 5-foot-long arm with a hand-sized scoop. This device was designed to dig into the soil to determine bearing strength and other characteristics. It dug several trenches in the lunar crust. It dumped samples of lunar material on its footpad, allowing close examination of the freshly disturbed soil. In other tests, the scoop was deliberately dropped on the surface, and pictures taken of the resulting dents and cracks. Another surveyor experiment used this alpha scattering device to determine the chemical composition of the lunar soil. At one point, surveyors' cameras interrupted their look at the moon to record this event, an eclipse of the sun by the Earth. The most important scientific conclusion drawn so far from all these photographs is that the moon's ancient surface is still slowly undergoing change. This has been caused mainly by the jarring impact of objects hitting the moon. But whatever the cause, the moon is not, as we thought, a perfectly preserved relic of the geologic past.